Students, in this video we will be looking at 4 special angles. Sorry about that, 4 special pairs of angles. That's a real important word. And 1 postulate and 3 theorems. Okay, that is our goal for today. Go ahead and copy this heading in your notes if you would, please. Write down pairs of angles and angle theorems. Pairs of angles and angle theorems, lesson 2.6, and include today's date if you would, please. Copy all of this down. For your heading today, pairs of angles and angle theorems, lesson 2.6, and include today's date. Now let's start off by looking at 4 definitions. You are responsible to know these definitions. Please make note that all terms, please listen to me carefully, that we are defining are dealing with pairs of angles. So all 4 of these definitions that you're about ready to write down are referring to angles that come in pairs of 2. Please don't forget that, okay? With that in mind, let's go ahead and get started with your 4 definitions. Here's the first definition I would like you to write down. I will pause for a second while you write this down. Vertical angles. What are vertical angles? They are opposite angles that are formed by 2 intersecting lines. Vertical angles are opposite angles that are formed by 2 intersecting lines. Take a second, copy that down, and then I will give you a picture of it that I want you to put underneath this definition so you have an example of what I'm talking about. Opposite angles that are formed by 2 intersecting lines, okay? And then copy this down, please. Copy this, put a line here, and a line here, and here, and here. All right, write this down, please. We'll call this angle 1, 2, 3, 4. Please quickly copy this in your notes if you would, please, and then write this underneath your definition. Angles 1 and 3 are vertical angles. I'll just put VA. And angles 2 and 4 are vertical angles. Isn't that easy? So when 2 lines intersect like this, boom, boom, just like that, this angle with 1 dot and this angle with 1 dot are vertical angles, and this angle with 2 dots and this angle with 2 dots are vertical angles. Okay? So 1 and 3 are vertical angles, and 2 and 4 are vertical angles. Easy, guys. Piece of cake, no problem. Opposite angles that are formed by 2 intersecting lines. Okay? All right, moving on to definition number 2. A linear pair. Linear pairs are adjacent angles whose non-common sides are opposite rays. Now I'll give you a picture of this in just a second, okay? But copy this in your notes if you would, please. Linear pair, adjacent angles whose non-common sides are opposite rays. Adjacent angles whose non-common sides are opposite rays. Okay, that's what a linear pair is. Now let me give you a picture of it, and it's really easy to understand, students. I'll wait just a couple more seconds, let you guys get caught up. Okay, here we go. Draw a straight line like this, and then draw a line coming off of it like that. And that's it. Call this angle 1, if you will. Call this angle 2. And then you can write off to the side. Angles 1 and 2 are a linear pair. It's that simple, students. Do you know what you need to have a linear pair? You have to have a straight line, and then a line or a ray coming off of that line. That's all you need. In fact, that's exactly what you have to have. That's it. It's that simple. A straight line, and then a line coming off of it, and these 2 angles are what we call a linear pair. Doesn't that make sense, though? The reason they're called a linear pair is because you have a straight line like this, and so you have a pair of angles on a straight line. It makes sense. A linear pair. Okay, adjacent angles whose non-common sides are opposite rays. If that definition doesn't do a whole lot for you, then here's a picture of it right here. Okay, angles 1 and 2 are a linear pair. Moving on to our third definition, please copy this down. You study this since elementary school. You know this. Complementary angles, two angles whose sum is 90. Two angles whose sum is 90. I'll pause just a second while you copy that in your notes. Two angles whose sum is 90. Okay. Now we could write an example like this if you would want to. We could do this and then go like this, and we could say this is, I don't know, 55 degrees and this is 35 degrees. We have a right angle right here. Well, these two angles are complementary because if you take 55 plus 35, you get 90. And so these two angles here are complementary. You can write this down if you want to, or you could have two separate angles. You could have one angle over here that's 30 degrees. You could have one angle over here that's 60 degrees. And you would say, let's say this is angle 1 right here, and we'll call this angle 2. You could say angles 1 and 2 are complementary because these two angles add up to 90, correct? So, pretty simple. When two angles add up to 90 degrees, then you have complementary angles. Okay, moving on. Last definition, supplementary angles. Please copy this in your notes. Supplementary angles. Two angles whose sum is 180. So that's simple, students. Two angles whose sum is 180. Okay? Now it could be a straight line like this, like a linear pair with a line coming up. And we could say this is, you guys know that a straight angle like this is 180 degrees. You should know that. And so that means this angle here plus this angle here is going to be 180. So we could say this is 140 degrees. And this is 40 degrees. These two angles here, this angle and this angle, are called supplementary angles because their sum is 180. Or you could look at it like this if you wanted to. You could have an angle over here if you want to write this down. That's, I don't know, 70 degrees. And an angle over here that's 110 degrees. And you would say these two angles are supplementary because their sum is 180, or in other words, they add up to 180. It's that simple, okay? Now, let's look at a problem to review these four definitions. Well, really not a problem. Here's what we're going to do. You should have your four definitions written, okay? So underneath your four definitions, I want you to draw this figure, okay? So I'll wait just a second, just a second while you do that. Please go ahead and draw this figure in your notes. Two intersecting lines. We will call this angle here 3, this angle 4, this angle 5, and this angle 6, okay? So please copy this in your notes. Give you a couple more seconds and we're going to move on. We do move fast in this class, okay guys? We have a lot to do. Okay, I want us to write down all the vertical angles that you see. Remember, vertical angles come in pairs of 2. Alright, so here we go. Angles, you can work ahead or stay with me. Angles 3 and 5 are vertical angles, and angles 6 and 4 are vertical angles because these two angles are across from each other and these two angles are across from each other. Remember, you have to have two intersecting lines, okay? And we definitely have two intersecting lines. Okay, a linear pair. A linear pair is when you have a straight line and then a line coming off of it. So here's a straight line right here. And here's a line coming off of it. So angles 3 and 4 are a linear pair. But hold it, there's another line. Here's this line right here. There's another line coming off of it right here. And so angles 6 and 5 are also a linear pair. Okay, and we're not done yet. I'm going to change colors here because I'm just so creative. Here's a straight line right here, right? Now look, we have a black line coming off of it right here. So angles 4 and 5 would be a linear pair. Angles 4 and 5. And then we have a blue line or ray coming off of the green line over here. So angles 3 and 6 would be a linear pair. So there we go. That's all the linear pairs that we have on this diagram. Okay? Now, do we see any complementary angles? Not necessarily. I mean, not necessarily. There could be, but it's just we don't know for sure, okay? So we're going to put for that, not sure, or not for sure, I guess I should say. Okay, either way. Now, supplementary angles, well, think about it, guys. Students, watch this. If I have a straight line like this, put a little point right here, you know that a straight line always has an angle measurement of what? You should know this. It's half of a circle, 180 degrees. So, if a straight line always has a measurement of 180 degrees, and I have a line coming off of it like this, think about it, students. If this whole angle is 180, then that means if I take this angle here and this angle here and add them together, I'm always going to get 180. Do you see that okay? So that means all of my linear pairs have to add up to 180. So which angles are supplementary? Well, all of these angles right here. I mean, well, let me do this real quick here. Students, hold on one second. Thanks for your patience while I do this. Okay, here we go. Now, which angles are supplementary? All of these. Watch this. Wow, am I good or what? Actually, don't answer that question. There we go. All of these angles here are supplementary. I mean, if angles 3 and 4 are a linear pair, then they're supplementary. They add up to 180. If angles 6 and 5 are a linear pair, then they're supplementary. They add up to 180. If angles 4 and 5 are a linear pair, then they're supplementary. They add up to 180. If angles 3 and 6 are a linear pair, then they're supplementary. They add up to 180. Okay? So hopefully this has helped a little bit. If these videos, that's the wrong word. If these definitions, DEF, if these definitions are still a little foggy, you might want to watch this part of the video again. These terms are very important, and we will be using them throughout the entire year. Okay, so you really need to know them. Next, let's take a look at a postulate. Go ahead and copy this in your notes if you would, please. Postulate 11. It's called the linear pair postulate, and you know what? I just taught this to you. I just said, go ahead and copy this down, students, okay? Postulate 11, the linear pair postulate, and I just went over this in the last page. If two angles form a linear pair, then they are supplementary. There's really not a lot I can say about this except to draw a line like this, and draw a line coming off of it like this, and these two angles here, we'll call them angles 1 and 2, are supplementary because they're a linear pair. If two angles form a linear pair, then they are always going to be supplementary. Always, always, okay? So, if two angles form a linear pair, then they are supplementary. Not a lot more I can say about that. Moving on, you need to know that postulate, like you need to know all of the postulates that we cover this year, okay? Moving on. Lastly, let's finish up with three theorems. Three theorems, okay? Now, before I give you these theorems, I first want to explain what a theorem is, okay? And so let me go ahead and do that very quickly. You're responsible for this, so copy this in your notes if you would. A theorem is very simply a mathematical truth that has been proven. It is a mathematical truth that has been proven. Okay, that is what a theorem is, and so we're going to. It doesn't mean we're going to prove every theorem. It just means that it's a truth that has been proven, and we will prove some of them. Okay, but it's a mathematical truth that has been proven. So with that in mind, let's go ahead and take a look at our first theorem. Please copy this in your notes, students, if you would. Theorem 2.1, congruent supplements theorem. Theorem 2.1, congruent supplements theorem. If two angles are supplementary to the same angle or two congruent angles, then they are congruent. If two angles are supplementary to the same angle or two congruent angles, then they are congruent. I'll wait just a second while you copy this down. If two angles are supplementary to the same angle or two congruent angles, then they are congruent. Please copy this down. If two angles are supplementary to the same angle or to congruent angles, then they are congruent. As you're finishing that up, here is all that this theorem is saying, students. It's so easy to understand. Please watch this carefully, okay? Let's say we have angle 1 right here, and let's say we have angle 2 right here, and let's say we have angle 3 right here. Please copy this in your notes if you would, students. I think this picture is real important, okay? If I told you that angles 1 and 3 are supplementary, and I told you angles 2 and 3 are supplementary, then you know what you know? Notice how 1 is supplementary to 3 and 2 is supplementary to 3. So angles 1 and 2 are supplementary to the same angle. So I can state, based on theorem 2.1, I can state that angle 1 is congruent to angle 2. Now we're actually going to prove that in a second, and I want you to take some really good notes on this, okay? But before I prove it, I just want to use common sense, okay? Let's pretend this angle here was 110 degrees. You don't have to write this down, just watch this. And let's pretend this angle here was 110 degrees. Well, if these angles are 110, then this angle has to be 70. Now watch this. Angles 1 and 3 are supplementary, so 110 and 70 equals 180. Angles 2 and 3 are supplementary. Well, 110 and 70, they're supplementary. 110 plus 70 is 180, and 110 plus 70 is 180. So do you see that if this angle here is supplementary to this angle, and this angle here is supplementary to this angle, look at these two angles. They have to be congruent. They're the exact same measure. They have to be. So if two angles are congruent to the same angle, then these two angles will be congruent. I'm sorry, let me start over. If these two angles are supplementary to the same angle, then these two angles are congruent, okay? Now I'm going to prove this very quickly, and you know what? I don't want you to take notes on this. I want you to sit and watch, and please listen to me. If you want to take notes, feel free to, but I'm going to go fast. I want you to start learning something that you need to know. Students, this is so important, okay? Whenever you're proving a theorem, your if part is always your given. You might want to write that down. That would be good to write down. Your then part is always what you're proving. Okay? Pretty easy so far. Your if part is what you're given, and your then part is what you're proving. Now, let's go back to the pictures I had before. I had an angle like this. We'll call this angle 1. And we're going to put another angle here like this, angle 2. And then we'll put an angle like this, and we're going to put it 3. Now listen to me carefully, students. You don't have to take any more notes on this unless you want to. Just sit back and watch, okay? If two angles are supplementary to the same angle. I'm not going to worry about this phrase right now. Normally I would, but I'm just trying to do an easy, quick proof and just teach you how to do this, okay? So we're going to just go with this. If two angles are supplementary to the same angle. So that's your given part. So here's what I'm given. Watch this carefully. I am given that angles 1 and 3 are what? Supplementary. And I'm also given that angles 2 and 3 are supplementary. That's what it says. If two angles are supplementary to the same angle, right? So there we go. Then that's my proof part. So what am I proving? I'm proving that they're congruent. So I'm proving that angle 1 is congruent to what? Angle 2. Now here we go. Remember how we do this? Here's your statements. Here's your reasons. We did this in the past here. And here we go. I'm going to write this pretty quickly and pretty small. Again, just watch, okay? All right. The first thing I'm going to state is my given. So I'm going to put angles 1 and 3 supplementary, and angles 2 and 3 are supplementary, and my reason would be given. That's what I'm given, okay? Easy enough. Now moving on to number 2. What I would say next is that the measure of angle 1 plus the measure of angle 3 equals 180, And I would also put in step 2 the measure of angle 2 plus the measure of angle 3 equals 180. And how can I do that? Well, because what did I just state in step 1? I stated that 1 and 3 are what? Supplementary. And I stated 2 and 3 are supplementary. So if they're supplementary, I can definitely state that they equal 180. And the reason would be definition of supplementary angles. Because I just told you they're supplementary, and now I'm telling you that they equal 180. I can do that by the definition of supplementary angles. Now I can use substitution. Watch this. If the measure of angle 2 plus 3 equals 180, then I can pick this up right here and put it in for 280 up here. Okay? If angle 2 plus angle 3 equals 180, then I can pick this up and put it in for 180 degrees. So now I have the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. And what did I just do? I did substitution. Substitution. And now look, students, we have an equal sign. We can subtract from both sides. Look, I have angle 3 right here and angle 3. So I can subtract angle 3 from both sides. And I'm left with the measure of angle 1 equals the measure of angle 2. Now what property is that called? That's called the subtraction property, okay, of equality. But subtraction property is good enough. And then lastly, we're just one step away. Now we can state that angle 1 is congruent to angle 2, right? If two angles are equal, then they're also congruent. And the reason would be definition of congruent angles. There we go. Okay, so we proved a theorem. So let's go over this again. You need to know, again, you don't have to copy this down. I'm just trying to slowly introduce you to these proofs, okay? The main thing I want you to remember or learn is the if part is always your given, and the then part is always your proof part, and then you write down your given from your if part, you write down your proof part from your then part, and then you do the proof. And you can include a little diagram like I did, which you usually should do. It makes it more helpful, okay? All right, let's finish this up. Let me get a drink here. Okay, students, go ahead and copy this in your notes if you would, please. Theorem 2.2, congruent supplements theorem. Theorem 2.2, congruent supplements theorem. And it reads, it's just like the other theorem, only instead of using the word supplementary, we're going to use the word complementary, okay? So here we go. If two angles are complementary to the same angle or to congruent angles, then they are congruent. If two angles are complementary to the same angle or to congruent angles, then they are congruent. And so here it is. This is really simple, guys. Let's say this angle here is angle 1. I would write this down if I were you. This angle here is angle 2. And we're going to say this angle here is angle 3. And we're going to say angles 1 and 3 are complementary. Angles 2 and 3 are complementary. So, angle 1 is complementary to 3. Angle 2 is complementary to 3. So, angles 1 and 3 are complementary. Angles 2 and 3 are complementary. Notice how angle 1 and angle 2 are both complementary to the same angle, angle 3. So, because of that, we can state, based on this theorem, that angle 1 is congruent to angle 2. And I'm not going to prove this theorem because it would be identical to the last theorem, only instead of using the sum as 180, I would just use 90 degrees right here. I would put a 90 here and a 90 here, and instead of putting supplementary, I'd call them complementary, and everything else would be the same. So I'm not going to take time and do that. But this is what this theorem is stating. If an angle is complementary to another angle, and then another angle is complementary to the same angle, then these two angles here will be congruent. Okay, theorem 2.2. Okay, students, moving on to our last theorem, and we're just about finished. Theorem 2.3 is called the vertical angle theorem. I'm going to prove this, but it's a very simple, quick proof. Theorem 2.3, the vertical angle theorem. If two angles are vertical, then they're congruent. If two angles are vertical, then they're congruent. I will pause just a second while you guys copy this down. If two angles are vertical, then they are congruent. Very important theorem. Okay, underneath that, let's go ahead and get a picture of what the theorem's saying. Go ahead and draw some vertical angles if you would. There we go. And there we go. Did not mean to do that, that's for sure. Alright, here we go. Let's call this 1, 2, 3, and 4. Here's what we're saying. If angles 1, I would write this down. If angles 1 and 3 are vertical angles, and angles 4 and 2 are vertical angles, then we know what? We know angle 1 is congruent to angle 3, and we know angle 4 is congruent to angle 2. So, one more time, if two angles are vertical, then they are congruent. Got it? Okay, let's prove this, and let's do a really good job, okay? So here we go. Let me get this together real quick here. There we go. And let's pull this over yonder, to use a good southern word. And so let's see what we have here, okay? This is my if part, so this is my given. This is my then part, so that is my proof part, okay? If two angles are vertical. Now, in order to do this proof correctly, I'm going to put an angle here, and here, and here. Just trust me, okay? So, I'm given, go ahead and draw this diagram here. We're going to prove we're going to prove theorem 2.3. And again, why don't you go ahead and take notes on this one? I'll go really fast and then we're done for the entire video. So go ahead and take notes on this one. I want you to make note that the if part is the given part and the then part is the proof part. And then I want you to go ahead and draw this diagram and put angle 1 here, angle 2, and angle 3. And then we're going to say we're given what? Well, read it with me, okay? We're given that two angles are vertical. So we're given that angles 1 and 3 are what? Vertical. Okay? That's what you're given. What are we proving? We're proving they are congruent. So we're proving angle 1 is congruent to angle 3. Alright, well, here we go. Let's go ahead and get after it, okay? Now, again, you're not supposed to know how to do this on your own yet. I'm just trying to help you. Take some really good notes on this, okay? Okay, here we go. Number 1 is my given, so I'm going to write angles 1 and 3 are vertical. You always write your given first, okay? And I'll just put G for, I'll go and put given. All right, number 2. Now watch what I write next. I'm going to put angles 1 and 2 are a linear pair, and so are angles 2 and 3. Okay, so number 2 would be definition of a linear pair. Isn't that easy? Think about it. We know that angles 1 and 2 are a linear pair because of the definition of a linear pair. And we know that angles 2 and 3 are a linear pair because of the definition of a linear pair. Now, Mr. Earhart, why are you doing this? I don't get it. You're going to learn why as we do more of these, and you'll become better. Right now, I just want you to write it down. Just kind of look at the thinking process that takes place. I have a reason for doing this. Now, think about the postulate we just learned way back here. Let's see if we can find it real quick. Postulate, right there. If two angles form a linear pair, then they're supplementary. So I just stated these angles are linear pairs. So now look what I put. This is so cool. Students, watch this. I'm going to write, this is really neat. Watch this. Angles 1 and 2 are what? Supplementary. I'm going to write angles 2 and 3 are what? Supplementary. And the reason would be, you can put, if you want to memorize the numbers, feel free to. That's really hard to do. You know, postulate 11. There are so many we're going to learn. But if you want to put postulate 11, that's fine. On a test or a quiz, if you put postulate 11, make sure you're right. I just tell students to put this. I just simply write over here, linear pairs are what? Supplementary. That's good enough for me. Linear pairs are supplementary. Okay? And now look, once you've been taught a theorem, you can use it in your proofs. Once you've been taught a theorem, you can use it in your proof. So look back at this theorem we learned. Sorry, not that one. This one. If two angles are supplementary to the same angle, then they're congruent. So look at what I have. Angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2. So angles 1 and 3 are supplementary to the same angle, angle 2. And so based on that last theorem that we learned, you can state that angle 1 is congruent to angle 3. And what would you put for a reason? I would just put angles are supplementary to the same angle. That's your reason. And we just learned that. If two angles are supplementary to the same angle, then they're congruent. Okay? Really cool. So you're learning over and over how to do proofs. What you learned today is that the if part is always your given, and the then part is always your proof, and then you write out your given based on these words right here, and you write out your proof part based on these words over here. Make a little diagram if you want to. You should. And then go ahead and set up your proof and do the proof, okay? So hopefully this is making sense more and more little by little, okay? That's it on the video. Contact me if you have any questions.